Hi, welcome to Circuit Analysis. I'm Jesse, and this is an intro to OrCAD 17.4. In this video, we'll go over the history of Cadence, and then the three most notable programs within the OrCAD Cadence package, and we'll wrap it up with the various file types that are used in an OrCAD Cadence project. I'm thinking this will be the first part in a series of a few different videos. So this is what I have planned here. The overview is this intro video. And then I'll probably go over how everything is set up, the environment, and the settings that I use. And after that, go in depth on the three main programs, Capture, PSPICE, and OrCAD PCB. And then go into the Tickle scripting. And after that, hopefully finally get to some actual circuit design. So this is a real simplified diagram of the history of Cadence. And it started off in the 70s when the University of Berkeley came out with SPICE, and that was just a text-based solver. And in 1984, a company, Microsim, commercialized it as PSPICE. And then that was sold in 1998 to a company that made OrCAD. And the OrCAD package was sold in 1999 to Cadence, which had Allegro. And they merged it all together, and now it's a little confusing whether it's called OrCAD or Allegro or Cadence, but it has a whole bunch of programs that all kind of work together most of the time. So here we have the main programs that we're going to talk about up at the top. Capture, this blue one, is the one that you start with, where you lay out your circuit as a schematic. And from there you can go two directions. You can either go analyze the circuit in a PSPICE simulation, or you can go this way to the PCB layout and design the circuit board. And then this pad stack is just a little utility that you'll use to create the pads that you use for custom parts in the PCB editor. Down here we have a couple upcoming things to keep an eye out for. This system capture is something that is in the current 17.4 release. My license doesn't let me open it, but what it is it's sort of their attempt to merge everything in a cleaner, more intuitive interface. Because the interfaces between Capture and the PCB editor, for example, are completely different. And so this here, if it all works out, will be the future program where you can do everything in one program and it's more seamless. The other thing that's kind of exciting is a piecewise linear solver. So that is something they've been talking about for a few years. I still haven't seen it yet, but it will supposedly be very similar to Symmetric's Simplice, which I've done some videos on in the past. So here we are in Capture. One thing you might notice when you first open Capture is it asks you which version you want. I just do the regular one. The CIS one is if you have it linked to a database, and then you can keep all of your parts organized. And that would be like a Postgres or a Oracle legit database. But you don't need that if you're just by yourself playing around with it. So what you do from here is we want to make a new project. And this one I'm just going to call test 1, and it's going in this test folder in my C drive. And I'm going to enable PSPICE simulation. So now it's going to ask me if I want to create it based on a template. So in here there's a bunch of pre-made examples that you can start with if you want. So we're going to start with the boost converter just to do a quick simulation run. So this project's all set up for you. And here it is over here. We can close this start page. So you have to move down the tree. You can adjust these bars. And under this design here, this boost converter, double click, and that gives you the schematic page. The other things, and this is the project view over here. The other thing to note here is they've already set up a simulation profile for you. So you can double click on that, or you can click on this button here, or PSPICE view, let's see, edit simulation profile here, and that all takes you to the same sim settings. So here's the simulation profile settings. Now, if you don't have this in your project, you have to click this plus to create a new one and then give it a name. And this here is the first page where you put in your analysis type, so this is a transient, your run time, so this is 3 milliseconds. We're starting saving the data at 0, no maximum steps. And then this right here is all these different ways you can kind of automate it or run multiple simulations. So here you can set a temperature, you can save and load bias points, you can do, in the temperature, you can do multiple temperature sweeps. Here you can do a parametric sweep, so you can change the value of something and run a bunch of simulations with like a resistor with different values, for example. Here is the Monte Carlo and worst case. So Monte Carlo is where you randomly vary a bunch of parts and then you get a distribution of the output parameter. And then worst case is where you vary the parts and you get a sensitivity analysis of how sensitive each part is, and then you set those parts based on that to either their minimum and maximum value to create an extreme worst case for the parameter that you're looking at. Now on the left here we have the options. Well, there's the configuration files, and here you can include other external libraries of PSPICE parts. Then we come to the options, and these are all your standard PSPICE options that you would write in a PSPICE netlist if you were just doing it with text. So these are pretty much the same here. And these are the solver parameters. We have the auto convergence. They have some fancy stuff in here. Here's the bias point settings, and then the transient settings here. So this one you can select which solving method you want. So I pretty much just use the general. Sometimes I use this auto converge, and these I don't mess with a whole lot. Sometimes I change some of these transient settings. Now on the output file here, this is where you can select what you want in the output log file. So you can check or uncheck these boxes to have more or less information in the log file. So now if we want to run the simulation, we just click this little play button here. And that's going to open up this PSPICE AD program here. So here you see the waveform of the output. The input's a little hidden here. It's right here at 40 volts. And from here, you can get some cursors if you want to look at the waveform better. And here you can click with your left click and click with your right click to make another cursor. You can hold it down to drag them around, and then down here it'll show you the measurement at that point and the difference between the 2 points. The other thing is this zoom up here. You can zoom around. And then another thing that's handy is you can save the view. So if you go display control, here you have a few different names. You can save this as, I'll just call it view. Now this is saved here. So if I delete this and I want to get back to it, I can do display control and load that view. So now we're back. The other thing you can do here is you can add more traces. Here's all the traces, write an expression. The shortcut for that is just the insert button. You can add a a y-axis on the side here to put more traces on. And you can delete that. You can also add a plot window, so stack them on top of each other. Delete plot. The other thing that's real handy is you can do view measurement results, and that gives you this measurement down here where you can add formulas. So you can do things, here's all the formulas here. So if we want to know what the voltage was up here when this settled out, you can do y at last x, and then here we would put v of v out 1. So that's just the name of the signal. And there it is, 80.4 volts. So one thing that this doesn't do is there's no way to overlay multiple waveforms easily from multiple runs. They do have a thing where you can append a waveform DAT file. So if you run multiple simulations, you can merge the two data files together, and then you can kind of overlay stuff. But I don't even bother with that. It's honestly easier to just open a Paint program. I use paint.net, and I just do a screenshot with, I use Alt and then print screen button on the keyboard, and then you can get your Paint program going and do Control V here, and then that way you can do multiple ones and then just click between them to see how the waveform changes. You can rerun the simulation from here. Here's the same simulation settings, and you can press this button to rerun it. The other thing is to get more waveforms on here. If you know the name of the net, you can type it in here, and that you do V and the name of the net, or I and the name of the node. But you can also use these probes up here. So if you click on, this is the regular voltage probe, this is the differential probe, and this is the current. So if we want to get the voltage here, we can click on that, and you'll see that was added in as this one, and it's called L3. That's pin 2, I guess. So what you can do with the plots, a good reason to add a plot is if you want to do like a current and a voltage. So here we can take the current, look at the current through the inductor. So you have to put that on the node of the inductor. And now we have the current plotted up here and the voltage plots down here. Next, let's close this project because this is just a simulation project, and we'll try a real quick circuit for the board layout. So we'll close that. We'll just save it all. And we're going to do a new project, and we'll call this test board. And this one I'm not going to enable PSPICE. So we have a blank schematic here. So to add some parts, you press P for parts. And this is not very intuitive at all. But you have these libraries here, and you click the plus to add a library. Now here's the folder with all the libraries. You'll notice this PSPICE folder. These ones here have built-in PSPICE models, and then the rest of them don't. So we can look down here. These are a lot of symbols, but most of these don't have footprints either. Let's say we want to do an op amp. Do op amps. And maybe we want A741. We can look down here as an AD 741. Double click, place it. Now we can zoom in by holding Control and scrolling. And we can look at the properties by double clicking it. Here in the properties, you also may, when you first get in here, have it like this. You can click pivot to make it easier to read. And here you can filter by different properties. For some reason, it doesn't seem to want to show you all of them at once. But in the capture one here, you can see PCB footprint is empty. This doesn't have a footprint. In the PSPICE one, you can see PSPICE template is empty. That means it doesn't have a PSPICE model. So to do a quick demonstration, we're going to have to use some parts that I already made. And let's just link a built-in symbol. Let's just do 2 bananas with a resistor between them, something real simple. The resistor's in the discrete library. We can press R to find the first thing that starts with R. It's just an R. I'm pressing R also to rotate once I have this part here. Escape, W to connect them. And you can move these reference designators around too just by clicking and dragging on them. Save with Control S. And you'll notice these DRC issues we have here. There's 2 warnings and an error, and that's saying the first one, the PCB footprint is missing from R1. So we can go into here, and sure enough, there's no PCB footprint. So there are some footprints that come with OrCAD, and they are in this path here. So if I click on here, I can type RES real quick for resistor. And here are a couple different things here. Here's RES 800. So if I copy that, these are the footprint files, .dra. I can put that in this PCB footprint property here and apply that. Control S to save it. I don't think you have to save it. I think if you just close it, it stays there. And you'll notice that this error went away. Now we're ready to send this over to the PCB designer. We do that by clicking Launch Design Sync. And here we can tell it the folder name we want to put the files in. Just use the default. That opens up the PCB designer. Now to place the parts, we click Place Components Manually. And you'll see here are the 3 parts that we just made. But you'll notice this R1, we can place that. So you click the checkbox and then you just click again to place it. But the 2 bananas are not showing up. So to get them to show up, we have to pull up our project file, and they aren't in the built-in directory. They were custom ones that I made. So to add those, we have to make a new folder, and we call it symbols. And I'm pretty sure this, you have to call it symbols, that's a built-in one that it looks for, is a folder in your project folder called symbols. And in there, we're going to put a couple of files for the symbol. So I'll just copy that from my other folder. There's two files for the symbol, banana.dra and banana.psm. And now you'll see this one, it says cannot load symbol banana. So now if we click on here, cancel this and place it again. Now it says not found in search 340R210. Now that's the name of the pads that go on the symbol. So we have to copy the pads in too. So that's this file here. Now that we have that, place manually, and we can select these, and now we're able to place them. To add traces, you click on this trace button, put in your width here, we'll make it 30, some mils. Click to start, click to finish, click to start, click to finish, and then spacebar to finalize the last finish. There's a lot of interesting, unintuitive commands in this PCB program. I think we'll leave it here for now. For more in-depth tutorials on the PCB editor, I recommend this guy here. Check out his YouTube. He has lots of videos on this kind of stuff. The last thing I want to go over is just the general file types in the project. So here I have a list of the main ones. So these are for capture, these are for PSPICE, and these are for the PCB editor. So for capture, we have the main project file, the OPJ file. That one's right here for our two files, test files that we did. And then we have the DSN, the design file. So those guys are here. And then we have this backup file. You'll notice if the program crashes and you open it again, it'll ask you if you want to continue with the backup. So it's constantly making that. And then it has this folder tree in here where your PSPICE files go. So like if you look at this test board one, there's nothing in there because we didn't do any PSPICE. This other one, test one, it has some files in there. So these are the PSPICE files. And if you go in here, there's the .lib file, which is a library file for PSPICE libraries. And then the .cir file, that's the top level circuit PSPICE file. So that one is in the analysis folder. So the transient analysis has transient.cir. So you can see that one here. It just has the type of analysis, and then here it includes the next file. No, not the next file, but this net file, the main netlist file here. Next file on the list is this sim file. That one's back here, transient.sim, and that one is a text file that just has all the sim settings from the sim settings dialog. So this is more for the GUI, whereas these sim settings here are the ones that are copied onto the actual netlist. So this CIR file is kind of like going to be pasted at the top of the netlist. And the netlist is not really all put together in one place where you can view it. The netlist is included, it's built through a bunch of inclusions. So this file is part of it, and then the actual .net file here is part of it as well. But it'll also link to other libraries that are built in. So the PRB file, that's this one right here, and that, kind of hard to read, but that's when you save those display controlled waveforms. So you can reload those with this .prb file. So you can copy that between projects if you want to reload standard waveform views. And then the .out file is the log file. And that one is here in the simulation transient folder. Since we did a transient analysis, so that's got the log here, and you can adjust that, like I was saying earlier, in the simulation settings with the checkboxes of how much info you want in this file. So that's it for the PSPICE. The PCB editor has a .pad file, the pad stack file. So we had an example of that here. And then the .dra file, that is this banana plug footprint, the whole footprint that references this pad. And I didn't mention this file. I guess this is part of the footprint file. It's these two files. And then the OLB file is a library file, which I don't have listed here, but if you make a custom library, or you saw it in the capture when you're selecting your parts libraries, they're .olb files. And BRD, that is the board file for your PCB layout. And that one is in this Allegro folder here. So here's the BRD file. And the final one here, this is one that we didn't talk about at all yet. But when you're making a board layout that has a bunch of sections that are the same, you can create a template, and it's this .mtd file. And with that, you can reload in the same layout a bunch of times, so you don't have to do the same layout if you have multiple versions of the same thing. So that concludes the tutorial. If you've got any questions or suggestions of things I should go over in future videos, let me know in the comments. Thanks for watching.